Hello everyone, welcome to today's webinar, The Zero Carbon Mine, part of the ESG Showcase series. I'm Tim Buckley, Austmine Membership for South Australia, and I'm your host today. Before we begin, on behalf of Austmine and all of today's presenting companies, I'd like to acknowledge that I am hosting this webinar from the lands of the Kaurna people. We acknowledge the traditional custodians of the various lands on which we all meet today and recognise the Aboriginal and Torres Strait Islander people attending this webinar. The ESG Showcase series is designed to provide our members a way to showcase their solutions while sharing valuable insights to help overcome key ESG challenges. The webinars cover various topics and highlights the innovative solutions and technologies the met sector is contributing to mining's sustainable future. Today, we continue the series with the Zero Carbon Mine, delving into technologies and solutions around sustainable mining operations, zero carbon power solutions, and zero emission powertrains for mining haulage, just to name a few. Next slide. I'm joined by 5 industry-leading member companies sharing their technology innovation success stories today. Joining us to share their expertise is Dane Noble from AECOM, Ben Connolly, Aviva, Jan Hack, First Mode, Dominic De Cruz, Zenith Energy, and Mark Keogh from Yuon. Next slide, please. The format of this webinar will include a short presentation by each of our presenters, followed by a Q&A session. If you have a question for any of the presenters throughout the webinar, please type them into the Q&A box at the bottom of your screen. And if your question is directed to a specific presenter, please note their name in your question. That concludes the welcome and introduction. So without further ado, I would like to welcome our first presenter, Dane Noble, Associate Director, Resource Powertrain and Industrial Lead at AECOM. Thank you, Dane.
Thank you very much, Tim, and good morning and welcome, or good afternoon, depending on where you're dialing into. My name is Dane Noble, as Tim introduced me. I am the Industrial Decarbonisation Lead for AECOM, located on Kaurna country in South Australia, and today I am joined by my co-presenter from Baker Hughes, Jeremy Campbell-Ray, who's joining us from Perth. We want to touch a little bit today on decarbonising the mining sector, but in particular focusing on hybrid energy systems and the opportunity to further decarbonise these exciting area of technical development within the industry. Just a very quick disclaimer, obviously this webinar is provided as general information only. It is not intended to be professional or legal advice. All right, so power within the mining sector. Typically what we see is generally we have loads sort of anywhere between 25 and 125 megawatts of sort of maximum demand or peak, with average demand somewhere sort of sitting just below that. Now, depending on where those demands are connecting into, if they're connecting into the sort of some of the major transmission grids across Australia, will then dictate what the effective carbon emission intensity is of that connection. So the map you'll see here highlights some of the major grids across Australia. We have extending from South Australia, assets such as Olympic Dam and Prominent Hill, Carrapateena, all the way down through into Victoria and Tasmania, and then up the eastern seaboard. That's known as the National Electricity Market. And then as we move into further into northern Queensland, we then have the Northwest Power System, and that serves the Mount Isa region and all of the mining assets that are located there. Predominantly gas generation within that grid, with a little bit of solar at the moment provided by the Dugald River Solar Farm. We then move over into Northern Territory. We've got some sort of smaller grids within the Northern Territory before we head into Western Australia, and obviously the major grids within WA being the Northwest Interconnected System up around sort of the Pilbara region, and then further to the south we have the Southwest Interconnected System. So depending on where your asset is connected, you've got effectively the carbon emissions associated with that grid connection, and that's usually expressed within tonnes of carbon dioxide equivalent, or CO2e, per megawatt hour. So for assets that are lucky enough to be located within close proximity to some of these major transmission grids, there's a relatively straightforward pathway to decarbonise your Scope 2 emissions purely by doing things such as signing up to green energy PPAs with some major energy developers. And we've seen quite a lot of that activity recently for some of the major mining assets. But for those operations that are not fortunate enough to be located within an economic location close enough to any of these major transmission networks, typically what we see is major standalone power systems serving those operations, or SAPs. And these typically have always relied on fossil fuel generation in the form of either diesel gensets or gas turbines or gas engines. And they obviously have a much higher sort of embodied carbon associated with them. Luckily, within Australia, we have a very high coincident wind and solar resource, which is also displayed on this map. And you can see where you've got overlaid high wind and high solar with high capacity factors. You have a fantastic opportunity to decarbonise your energy system. And for those that are a standalone power system, this is typically provided by a wind, solar with some short duration storage in the form of a battery. And then obviously you have to have some firming there as well for when the wind's not blowing and the sun's not shining. That's typically still provided by more traditional thermal generation assets. So if we look at an example system, what we find is the techno-economics largely stack up for achieving about 85% renewable penetration. And what that means is that over the course of any given year, 85% of your load is met by renewables and firm storage provided by that renewables. So that means we've still got 15% that we rely on for more traditional forms of generation. Typically, as I said, that's thermal generation, diesel or gas. So the graph on the top right-hand side, you can see here, anything below the line is the load being met by wind in green, solar in yellow, and then the battery in the red color is where the battery is discharging. And then those little pockets of brown, that's actually the thermal generation. So in this scenario, that makes up approximately 15% of the overall energy mix. And then everything above the line, we see the battery charging. And then for when the battery's full, we then get all of the blue area, which is effectively spilt energy. So it's wind and solar that's not able to be captured and therefore is curtailed or is spilt. So that is the opportunity we want to touch a little bit on today, is how can we make that additional spilt energy further decarbonise the standalone power system. And that's typically about 25% of total generation is spilt, is what we're finding. Just to quickly touch on the graph below that, this shows some of the economic trade-offs, and what we're trying to achieve in these systems is the lowest levelized cost of energy. So that's the long-run marginal cost of these energy systems. And where that lowest point sits is ideally where we want to size our renewables and storage, because as the orange inverted hockey stick demonstrates, we then get diminishing returns as we overbuild our renewables. So putting in too much wind, putting in too much solar, what that means is our LCOE starts to go back up and our renewable penetration does increase, but it also means a significant amount of additional CapEx. So the economic case at the moment, we see, as I said, it sits at about 85% thereabouts for renewable penetration. And we want to try and then capture the remaining 25% of spilt energy to try and offset that 15% of otherwise typical thermal generation. So this, again, this is just an example, but this is for a system where we've optimized for the lowest LCOE. We've put in 48 megawatts of wind, 44 megawatts of solar. We're saying about 25% of the total generation is going to be spilt. So we want to capture that. We then want to turn that back into hydrogen and store that hydrogen through an electrolyzer and a storage mechanism. And then we want to run that back through our thermal generation. And that thermal generation, there's the opportunity for it to be capable of running on either 100% hydrogen or a blend of hydrogen and some other thermal sources. So there's obviously a lot of challenges associated with this, and we acknowledge those. We've listed them on the right-hand side, but there's also opportunities. So today we're talking about, optimizing and using some of that spilt energy to convert it to hydrogen and then put it back through our thermal generation assets. But there are other opportunities such as fuel cell electric vehicles, capturing that hydrogen using in FCEVs, and other opportunities as well. So I'll now pass on to Jeremy, who will run you through some of the exciting technology developments that Baker Hughes have on offer. Thanks, Jeremy.
Thank you, Dane, and good day to you all. I'm glad to join this webinar and build on Dane's presentation to discuss some enabling technology to support net zero mining operations. As an introduction, Baker Hughes is an energy technology company with extensive capabilities and experience built over many decades within oil and gas that we're now applying more broadly to enable the energy transition. We are ready to support the decarbonisation of mine operations with our power generation and microgrid solutions. Our experience with hydrogen is extensive. We operated our first 100% hydrogen turbine in 2009, and we have been compressing hydrogen since 1915. Our solutions include the Nova LT range of gas turbines that are capable of burning pure hydrogen in both 12 and 16 megawatt formats. They provide excellent fuel flexibility as they can consume hydrogen, natural gas, or blends in between, with the capability to transition across the range of fuels even at load. To date, we've sold 9 units for hydrogen duty, with the first units running on hydrogen blends fully tested and already in service in pipeline applications across Europe. The Nova LT has a 4-year maintenance interval, and when service is required, they can be swapped out in 24 hours, meaning that we provide class-leading availability while bringing reliability performance built on years of gas turbine design and operations within the oil and gas sector. The Nova LT offers operators flexibility through its class-leading partial load efficiency, ideally suited to microgrid applications with variable load demand and supply profiles. We're also developing our microgrid capabilities to enable the integration of renewables following our acquisition of Brush Power in 2022. We're also proud to offer synchronous condensers as well as energy and power management systems. Thank you. Back to you, Tim.
Great, thank you, Dane and Jeremy. Next up, I would like to welcome Ben Connolly, Director, Industry Strategy at Aviva. Thank you, Ben.
Thanks very much, Tim. And thank you, everyone, for allowing me to talk a little bit about Aviva and our solutions for the zero carbon mine. Okay, so maybe just I'll start with a little bit about Aviva and why I'm here talking to you today. So Aviva is a world leader in industrial software. And if you've been involved in the heavy industry for any length of time, you will have come across one of our tools or platforms in your day-to-day work. And a couple of years back, we merged with OSIsoft, bringing together the world-leading operational data management of the PI system with our innovative industrial software to really empower teams and enable even higher levels of performance. So our business is founded in trusted partnerships with our customers, who are the leading industrial companies across the globe. And they use our expertise in our products to unify their data and combine it with leading-edge analytics, and ultimately turning those opportunities into sustainable business value. And as an industry leader, we know that much is expected of us, and that's why we've articulated a vision of three ways we can demonstrate leadership across our environmental, social, and governance agenda. And our technology handprint is really where we help our customers directly in their journey through transforming the energy efficiency, the circularity, the traceability, and the resilience really of their business via our secure software. And the actions that we take daily to further embed the sustainability into our operations and our culture and our core business strategy are really guided by our overall ESG vision. But really, what do our customers in the broader industry have to say? Well, a survey commissioned by Schneider Electric and IDC asked a number of companies what sustainability-related capabilities they either have or are planning to develop to support their sustainability initiatives. And the results are really quite telling. And there's been a big focus on formal programs and improved processes at a business level, but little focus on practical solutions at the plant floor. And this is really where we see the most improvement can be made. And an analysis of the revenue growth and profitability of industrial companies globally has showed us that those with a committed and ongoing sustainability-based strategy, combined with a long-term funded and committed digital transformation agenda, considerably outperform their competitors. And for mining companies, the ability to successfully drive sustainability through every part of their business, supported at a strategic corporate level by meaningful business practices and operational and technology approaches, is really a critical element of a thriving mining, minerals and metals sector going forward. And technology and digitalization plays a key role in enabling the required monitoring and recording of operational parameters, as well as automating and operationalizing data insights to deliver those sustainable outcomes across the mining value chains. And mining organizations cannot really set strategies and targets or manage and report on information across silos using manual approaches. So these initiatives will really require visibility, optimization and automation supported by software with integrated cloud platforms and data collected through instrumentation and connectivity, really. So these systems will allow companies to more easily provide the required visibility and enable the capacity for optimization and automation. And this visibility will really be required to deliver and execute on strategies for sustainable, efficient, and productive outcomes. Now, the majority of Aviva's global mining accounts have set ambitious targets, emissions reduction goals, for 2030, and many have committed to net zero by 2050. And so we're living through a time of huge disruption and incredible innovation. And with the clock ticking on delivering the 2030 agenda for sustainability, sustainable development, we're committed to being part of that solution to a more socially just and environmentally sustainable world. And as the world's leading industrial software company with a presence in thousands of mining operations globally, we have a real responsibility to provide sustainability solutions for the industry. We take it seriously, and we're equipping our customers with innovative and practical solutions to achieve and exceed these goals. So today I'm going to talk about just one example of how our technology in handprint, in other words, our platforms and applications, can help our customers in the zero carbon mine transition. So achieving continuous improvement in sustainability requires a step change from simply reporting energy and water usage, dust, noise, and greenhouse gas emissions. And just as understanding the root cause of delays and rate loss is essential for optimization of production and maintenance processes, understanding the root cause of water and energy events is critical for continuous improvement of our sustainability measures. We really have to be able to answer questions such as, why did we consume more water and power per ton than we targeted? What are the causes of our peak energy events? Why are we only finding out about these incidents at the end of the month when it's too late to act? How can we make sure that the data is accurate and reliable and auditable? And how do we ensure our sustainability goals are being considered in the control room decision-making process in particular? What we need is a solution that should be very familiar to those who have been involved in continuous improvement processes, particularly around equipment availability and ensuring production processes consistently achieve maximum sustainable rates. We need a platform where energy consumption as well as other sustainability factors are recorded alongside production and operational information. This information is derived from source sensors and other control information and environmental systems. It'll have human context added where necessary. It's got to be readily available to real-time decision makers, such as those control room operators I mentioned earlier. And we must have the ability to collaborate with remote experts via familiar tools with access to all the available context. We really need a common platform for operations and ESG teams to allow the elimination of spreadsheets and legacy tools and provide that essential auditability and accountability for the organization. Now, thankfully, we have a solution, and the building blocks are already in place at thousands of mining operations around the globe. The answer for us is Aviva Pi system with Aviva Production Management, formerly known as AMPLA. Now, accounting for lost production time or reduced production rate has been an essential tool for continuous improvement processes over 20 years, and Aviva Production Management has been at the forefront of that movement. It's really provided a reliable and scalable tool set to model and monitor operations from a single site to multi-site and global supply chains. However, greater productivity cannot come at the expense of environmental sustainability and social responsibility. So understanding the performance, inventory, and sustainability of operations in near real time is essential. And Aviva Production Management, with its industry-leading capabilities in performance monitoring and inventory management, provides those necessary tools and best practices to progress from efficiency to eco-efficiency. And it allows you to instantly report and analyze energy and production context alongside other sustainability levers such as water consumption. And it provides those expected versus actual usage information according to actual tons and feed material, not just according to plans and budgets. And it provides full traceability and root cause analysis of overconsumption events, just like we've come to expect for downtime and performance loss over the last 20 years. And ultimately, it allows for the real-time calculation of sustainability KPIs, which can be combined with OEE or asset utilization KPIs to drive better control behaviors and essentially democratize your sustainability goals by providing the control room with visibility of how their decisions affect the sustainability of your organization. Okay, so there's a lot to be said on this topic, and unfortunately we have very little time in this webinar. So I encourage you to check out the Aviva website to understand how other customers have utilized our solutions to drive their zero carbon initiatives. You can also check out the YouTube channel for Aviva Production Management, which has a number of technical videos as well as new ways of working, specifically designed for the mining industry. So thank you for your time. Sorry that it was drinking from a fire hose, but please feel free to reach out to me personally for more information or to set up a time with one of our industry experts who can help you on your journey to become a zero carbon mine. Thanks, Tim. Back to you.
Thanks, Ben. Great to see a practical solution that helps operators and supervisors contribute to sustainability programs. Having a solution like this that'll empower operators to report and optimise this in real time is very exciting. Next up, I would like to welcome Jan Hack, Vice President of Business Development at First Mode. Jan, the audience is yours.
Thank you, Tim, and hello, everyone. Thank you so much for your time. I'm really excited to talk to you today about First Mode's path to zero. This is one of the first times we'll be talking publicly about some of our product development. So, thanks for being here. First Mode exists to accelerate the path to zero for the industrial sector. And we are starting as a business in mining. And so what I was hoping to do over the next couple of minutes was talk about who we are as a business, give you some background into the work we've done and some of the achievements to date, and how we're scaling that work moving forward. And I think moving forward is a really key term here. We're really focusing on ways that customers can work in a feed-forward manner. So get started now without diminishing the possibilities of what you might be able to do in the future. And so we started in 2018 with a bunch of folks with some incredible experience in deep space systems engineering from NASA and asteroid mining companies. And one of the many projects that we were operating on as a consultancy was creating a zero emission ultra class mining truck for Anglo American as a customer. And that really was part of the motivation for me, in fact, in joining First Mode. It was such an incredible project. But when we talk about now, we're at the point where we've got nearly 400 staff globally. We've got a background in mining, a background in aerospace, some incredible folks having built some scaled manufacturing technology businesses in the past. And we have an expanded mix of products that are focused on converting existing haul trucks that are already in the field into hybrids, into battery electric powered trucks, and onto hydrogen fuel cell powered trucks. So if we go back about go back to that 2018, 2019 period, this is the project that kind of kicked off where we're focusing on as a business. We built the world's largest zero emission haul truck for Anglo American. And we deployed it onto an active mine site, Mogalakwena in South Africa. Now, this was an incredible technical challenge. Nobody had ever put this many fuel cells together and combined the power of them on or off the planet before. And it was a hybrid design with fuel cells and battery power firming some of that energy. And so there's actually almost 20 Teslas worth of lithium batteries on this powertrain as well. So there was some tremendous world firsts in integrating that onto the truck and allowing the truck to operate in a mine site. But there was also a huge amount of change management, training and safety work, ensuring that this vehicle was able to interact on a live mine site, as a part of the mine. And so that comes with training and certification and skills development and a whole ecosystem around it that we had to work on. And due to the success of this proof of concept, we ended up with a commitment from Anglo American to supply more than 400 powertrains for their trucks all around the world. And that's effectively what's allowed us to turn into more of a product-focused business. So when we talk about that initial hydrogen fuel cell powertrain, that's the archetype you'd see on the far right here, which is a hydrogen fuel cell electric vehicle. Now, powered by liquid hydrogen, this design enables you to effectively run your mine as though you're still running on a diesel truck. The amount of energy that you can store on the vehicle means that there's no need for frequent refueling or recharging, and it's certainly one of the ones where you will get a huge amount of flexibility on a mine site. You also don't need power infrastructure like you might do for battery electric charging. And take a step back and make that system a little bit simpler. Every truck we work on has a battery on it already. Now, one of the convenient things about these diesel electric, what's already called electric trucks, is that they have had electric drive motors for more than 20 years already. And so when you brake, you're actually running the wheel motors as a generator. And so you're able to capture that energy in a smaller battery and use that energy. Instead of turning it to heat, you can use it for diesel reduction. So that is what is represented on the left by the diesel battery hybrid. And the idea of starting with a hybrid is you don't need refueling infrastructure, you don't need hydrogen, you don't need a battery charging system, where most of our customers want to get started today, but don't necessarily have the hydrogen or the power infrastructure they need to decarbonize their site rapidly. So what we're doing with customers now is starting with this hybrid system, which can be deployed really rapidly across a fleet without that infrastructure, and then allowing customers to kind of make the call as to whether they want to put on go with an all battery solution, which has an incredibly efficient use of renewable energy, if that's available on site, or the fuel cell option. So this is certainly the way we're talking about it on the truck. However, this problem is far more than just about a truck. And I think being a part of this presentation, when you're talking about all of the folks that are making and generating hydrogen or bringing renewable energy to site, our customers across the planet are grid connected, but are power constrained in their ability to bring energy on site. They have to build their own grid in many cases, certainly in Australia and Canada. And so when you look at that bigger picture, the training, the power and the hydrogen sourcing, how you even think about maintaining this equipment has to change. So we're building our own liquid hydrogen refueling system. We're working on our own battery rapid charging, but we also want to interact with the systems that customers already are thinking about bringing on site. This really goes back to trying to disrupt a supply chain of diesel, which is very mature and more than 100 years old, and it really goes to be much more than just the truck. And I think by focusing on trucks that are already on site, we want to be able to reduce the friction of being able to move really quickly. The hybrid truck that we're talking about, in some of the sites we're looking at, will save 30% of diesel, which is an incredible amount of energy and money saved, and correlating reduction in emissions. So in terms of who and where we are and what we're doing moving forward, we've got heavy engineering labs in Seattle and in Perth in Western Australia. And our first manufacturing plant will actually open later on this year in Washington, in the United States. And it is a factory that is designed to be incredibly adaptable to an evolution of products that we're bringing to market. We've also leased a proving ground in southern Washington, a coal mine that's under reclamation, and we are using that to prove all of our vehicles in a real environment. In closing, these solutions are looking to be ready in 2025, and the impact of the work that we're doing is incredibly motivating for our team. We really want to move faster than the OEMs are able to, and be able to bring a product to market that's best in breed. Climate change is a huge challenge, and that's not going to happen without increased mineral extraction. And this is a huge impact we can all make in emissions reduction. Thank you very much, Tim.
Thank you, Jan. Very interesting to see the advances that First Mode are making in that space on decarbonisation for the mining industry. Next, I would like to welcome Dominic de Cruz, Executive ESG and Stakeholder Engagement at Zenith Energy. And Dominic, you may begin your presentation. Thank you.
Thanks, Tim. Good morning or good afternoon, depending where you are today. The presentation this morning is about Australia's first off-grid at-scale engine off project, which is at the Nova Power Station for the IGO Nova Nickel operations in the Fraser Range. Very quickly, the disclaimer, which was mentioned before at the start: this is not specific advice for anyone, but general in nature. As a start, I'm not too sure how many people would be aware of Zenith Energy. It's an independent power producer. And I thought I'd, rather than listening to voices continually, would jazz it up a bit with a video so that you can see who we are through that medium. I might need some help to press play on the video. There we go. Oops. I need to pause and move on. Thanks, Danielle. Just a quick story about who Zenith are. It was incorporated in 2006, but had roots prior to that as a previous independent power producer called State West that was acquired by Wesfarmers, and that subsequently become EDL today, one of the three largest IPPs in the country. In 2006, founding chairman, executive chairman Doug Walker incorporated Zenith, and it listed in 2017 and then was reprivatized again in 2019. And our shareholders are, as you can see on the slide there, Civic Equity Partners, Foresight, which is a UK-based firm, and OP Trust, Ontario Pension Trust from Canada. The focus on the reprivatization was really around a growth strategy founded on decarbonisation. So the last couple of years have been a bit of a watershed for the organisation and the sector in general, really. The business operating model is build, own, operate, which means that we finance, design, build, operate and maintain all of the power stations that we own in a vertically integrated model. So all the expertise is in-house, or we probably outsource. Green construction is the civil work. Zenith has contracted and currently constructing most of Australia's off-grid high penetration renewable power solutions, and that has doubled since FY21 with contracted energy solutions, now numbering 20 and circa 700 megawatts of contracted capacity. In terms of our focus on decarbonisation as a strategic imperative, we set a net zero goal of 2035, and I believe we're the only IPP to have set that goal publicly. We're the only IPP in the Electric Mines Consortium, which is a consortium of miners looking to electrify mines to decarbonise and remove particulates from diesel at their sites. And we have also been the first IPP to form a collaboration agreement with a traditional owner group, and subsequently a majority-owned Indigenous joint venture focused on power solutions with Jawal, which is a traditional owner group in the Northern Goldfields, who have native title determined lands where there are a handful of miners operating already. Our glide path to net zero was something that we had to publish, I think, essentially to substantiate our net zero target of 2035. And I wanted just to talk you through that plan that we established only just over 12 months ago, and the progress that we've made to illustrate, I guess, the very quick changing nature of decarbonising in the mining sector. So we published in this journey, or this roadmap, based on a framework that was bounded by carbon intensity, which was mentioned earlier in an earlier presentation. So basically, tons of CO2 equivalent per megawatt hour generated, and active facilitation of emerging technologies or adoption of technologies that would get us to net zero. You can see there there's 4 stages that we've bounded using those 2 criteria, with 2 major milestones being 2025 to accomplish a 20% reduction in our carbon intensity, and 2035. Noticeable that we've accomplished that first milestone of 20% decarbonisation intensity, but in the last 12 months, contracting sufficient renewable capacity that will achieve that target for us. In stage 1 to 2025, that intensity reduction is driven primarily by adding renewable energy in bulk, which sounds simple, particularly today when you think solar and wind probably is a bit vanilla. But even 2 years ago, integration and the financials around integrating large amounts of renewable, there were probably the majority of people in the doubtful camp rather than in the advocate camp. When I joined in January 2021, I think expectation was that no more than about 20% of the power provided from an off-grid power solution would be renewable or could be renewable, either because it was too expensive otherwise, or the ability to integrate what was just difficult or unproven at that stage. Within 12 months, the benchmark had increased to 60% when we contracted the Liontown lithium project. And then within a couple of months of that, and within 24 months of us thinking that 20% was the limit, we contracted an 80% renewable energy penetration operation solution for the Bellevue gold mine, also in the Northern Goldfields. In fact, only about 10 kilometers south of the Liontown lithium mine. So the stage objective was really to facilitate or provide conditions that would enable the deployment of bulk renewable energy. And I think we've been able to achieve that, particularly in a greenfield scenario. But that's been off the back of us being able to demonstrate the case study, which I'll walk through the story of in the next couple of slides, which is the Nova Engine Up project. I guess what that's demonstrated is that we can operate a mining operation which is off-grid 100% on renewable energy continuously and for up to 9 hours. So the high levels of penetration and the integration issues around that are an issue, so that resolve the technical barriers. And the affordability is absolutely there in terms of being able to provide a levelized cost of energy over the life of the PPA, the power purchase agreement with the miner, such that they can achieve their decarbonisation goals. Stage 2, in that journey to circa 2030, and we're probably pushing that number up to 50% rather than 20 to 40% in terms of intensity reduction, is, we believe, going to come from the ability for us to facilitate commercial pilots of energy storage solutions, whether that be chemistries, a thermal solution, gravity storage, or green fuels, or potentially even application of carbon capture and utilization in thermal generation. And the ability to reduce the risk, all those things, what they achieve for us and for the miners is the reduction of stranded assets, because they are relocatable, modular. And what we are also looking at in terms of solutions is the ability to create shared infrastructure and interconnecting off-grid locations, which are in close proximity geographically, to be able to share renewable generation resources, particularly to reduce the amount of spillage that was mentioned also earlier. Working with like-minded clients and industry consortiums has been a real boon for us, because we all share the same decarbonisation goal, and that common ambition has been critical to having people take on the potential perceived risk of integrating large amounts of renewables and or trialing new storage technologies, and looking at commercial models that would otherwise have been probably not considered in terms of collaborating, interconnecting operations to share infrastructure. And we think those are all possible in the immediate short term for our stage 2. To get beyond that across our portfolio, to 80 to 100% reduction in our carbon intensity is all about scaling those technologies that we'll be able to prove up to 2030 and continue to deploy in any residual brownfield sites, insertion of renewables, or have those sites run off of our portfolio.
Dominic, I'll just need to give you another minute.
Sure.
Okay.
No problem. Thanks. So the story which has enabled both the development of our stage 1 and facilitating stage 2 has been the Nova site. We took that on in 2015, inserted some medium speed and high speed diesel generation sets. It's always been a diesel generating station. In 2019, we installed what was then the first commercial, and I say commercial as in no government grants funding for the project, for a hybrid project, a 5.5 megawatt single axis tracking system, which was affordable primarily because we avoided the use of having to insert a battery energy storage system by using cloud predicting technology and using the fast ramp rates of those diesel sets to be able to accommodate smoothing in essence. Then in 2023, we collaborated with IGO to be able to deploy a further 10 megawatts of relocatable solar, as well as a 10 megawatt BESS and synchronous condensers in order to provide, I guess, the security around that supply and reliability of where we could run the whole operation completely on renewables. The benefits of that project for us really have been the improving of speed and optionality, because the relocatable Nova is a site that only has about 4 years of life left. The ability for us to put down relocatable solar and move that to another of our geo sites in the future was critical to the business case, as well as the relocatability of the BESS system and the synchronous condensers. The optionality that provides is that flexibility, but the speed also, around mobilization at other sites for us, it was critical, because mobilization is a big fixed cost, and without with the relocatable solution, we can deploy and relocate without a lot of mobilization costs. Shared risk and shared reward was critical, which meant that both of us, IGO and ourselves, had to share the risk and incorporate that into the commercials of the PPA. I should also mention that it's not the first location where engine off has been achieved, but it's certainly, there's a 3 megawatt installed capacity site at Tellus, which had achieved that objective in 2020. But I guess the proof of the pudding is in the eating, and really that quote from IGO's CEO tells the story of the acceptance at the client side. Thanks very much.
Great, thank you for that, Dominic. And finally, it's my pleasure to welcome Mark Pio, founder and chairman of Yuon. And Mark, please provide us with your presentation. Thank you.
Thanks, guys, and welcome everybody, and congratulations to all the companies on their innovation and the works that they've been doing to date in this energy transition. I'm the founder and the executive chairman of Yuon. Yuon is a West Australian targeted integration company. We have 20 years of experience of continually innovating. We started off by recognizing the environment in Australia is different to other parts of the world in the sense of the environment, high ambient temperatures, cyclonic weather, solutions that needed to be reliable around energy and water management, and building in the capability to operate in those environments. So improving operational performance helps with fuel, helping integrate renewables and decarbonizations and technologies reduces the ongoing cost of fuel and diesel and the carbon, but ultimately delivering CapEx and OpEx savings across a full range of smart solutions. And that means measurable environmental benefits over to traditional solutions. So typically on a mine site, what we're looking at here in this particular overview is the areas of activities that typically go around the operation. So every activity requires energy, whether it's the installation of the equipment to the ongoing maintenance and operation. So across remote power generation, water management infrastructure, most importantly, the integration of renewables as we move forwards to this transition, Yuon have developed a lot of solutions which are effectively smart products, and they will give the benefit of that transition by way of improving the CapEx and the OpEx, and also meeting some of the ESG compliance requirements and the targets that our mining clients have set. So that's the mine that we would have developed over the last 20 odd years. This is how we see the mine of the future. So we're not effectively displacing the existing assets by getting rid of them, but what we're looking to do is to leverage those assets as standby. So mining companies have invested a lot of money into the effective equipment that they have for use in the day-to-day operations. So whether that's in pumping, to generators, to transmissions, pipes, to active power supplies. The key component here is the fact that they still maintain their asset value, but they also get longevity in the asset value, but that asset then becomes the standby of the future, not necessarily the primary source of energy. So with that in mind, Ewan has created a scalable, modular, automated, and renewable solutions to effectively provide the mining clients with a pathway. The solutions are manufactured in West Australia. We are the OEM. We've designed the equipment. We've provided our engineers with the access to the data for the equipment to be then built, but also controlled and maintained within West Australia. So we can support the equipment. So we're not bringing in solutions from overseas without necessarily the know-how, the local know-how to be able to support that product as we roll it out over the coming years. So what you're looking at here is one of our smart cells. It's a patented unit, and it provides a standard platform which integrates various different technologies. So it is the first system which is 100% renewable to provide EV charging for off-grid infrastructure. So that means no grid is required. It effectively can be put on the ground with the renewables inputs being wind or PV, and you have a full EV charging station for all your various different activities across your mobile fleet. So typically we have a number of different applications, which may be from providing power to trams, which we're looking to do in the next couple of weeks within the city of Cambridge, but also for mobile fleet. We've partnered up with Carbon, who is providing in excess of 500 EV vehicles for lease for mining applications over the next coming years. So this has a very easy, rapid deployment for areas that don't have grid or availability to power to provide the traditional EV charging solutions. It also can operate as a standalone power system. And in particular, we have it designed to meet with some of the dewatering requirements. One of the conversations earlier, we noted, I made the water overconsumption and the water energy and delivering energy and energy consumption is a key component, because if we don't have efficient equipment that's operating for moving your water, and you don't have the best energy solution for running that pump of operation, it then makes for an inefficient system, which in turn increases carbon. So we are also a manufacturer of Willow pumps, which are the most energy efficient pumps globally, and they've been recognized for that, and we are manufacturing those pumps in West Australia. And combining that with our smart cell solutions, it gives us a real value add for clients trying to meet with their decarbonisation journey. So this is a very quick overview of the what we call the smart cell. It has a battery motor controller for any motor operation, EV charging, and standalone power. So that is very important when you're looking at, well, what about the data, the integration, the analysis? The actual unit itself is able to comply and meet with some of the reporting requirements for ACCUs and LGC, so that they can either be transferred to the client, or else if it's leased off us, we can then provide you with some oversight as to what your utilization is and some of the emissions that you might take a benefit of. So Ewan Smart, in one of the applications being dewatering, effectively we looked at a base load of 145 kilowatt, and this has a total bottom line saving based on diesel at about $138, $1.38 a litre, of about 941,000. So that means you can replace for new equipment, for brand new installation, for everything, bottom line, less than 3 years payback. For existing installation, existing equipment, you can put this system in and effectively will displace the need for the diesel, either 100%, or if it's on its 24-hour cycle, will be on a 60% case basis based on the figures that you see there below. So the actual units themselves also operate within the precinct of West Australia for reducing energy consumption on the likes of construction sites, whereby you have a limit for the main supply, and that might be subject to the fact that the transformers need to be upgraded from your supply chain. We are able to limit the power supply to allow us to facilitate commissioning on the Parliament House recently in West Australia. So these are some of the power graphs that you're looking at here, where we see the baseline, which is the straight line, is the grid, which was limited, and where you then had the battery supplementing the power. And then at the end of the day, when the battery had discharged, effectively when everybody went home, the equipment itself was then able to maintain and operate the site as per requirements for the commissioning. So during the course of that 4 period, it effectively saved them in excess of $200,000 worth of rental, ordinarily from diesel generators, but also has a significant value in regards to the diesel consumption. So what is Yuan? Yuan is a vertical integrated supplier. We're an OEM of equipment. We understand the components of the systems, how to get the most of them. We're the software developers and we're the integrators. We've partnered with leading companies to provide the combination of best global technologies. These are ongoing discussions at a very high level with various different companies, but be rest assured we are dealing with the best in the world. We have a facility within West Australia. We have 4 locations. This is our workshop in Malaga. Basically, we're making locally. We have the benefits of in-house design, shorter lead time, single point of customer contacts. We create quality, and owning the IP drives and control and innovation is a very key component to support our clients' needs. So this is some of the assemblies and the testing as we've done over the last couple of months. We provided a recent show with the ministers coming down, and effectively quite surprised that you could come along with your EV vehicle in the middle of nowhere with no power supply other than PV, and we're able to charge vehicles. So this was looked upon very greatly as an innovation, and one that would solve some of the rapid growth in EV vehicles across mining infrastructure. So delivering that energy transition solutions help manage the customer's needs. This is one of our BMCs, the battery motor control unit, where we have the deployable 5B solutions, where effectively that is delivering in excess of 70% penetration with renewables as we speak today.
Just the last minute on this. Thanks, Mark.
Yep. This one here is another one where we do a hybrid system for power integration for one of the client's mineral resources, which is also part of the Yuan Smart family of products. Again, Yuan is committed to developing energy for every future through smarter, more reliable energy solutions, improved performance, manufacturing equipment locally, helping with that energy transition and security, experience in the integration of distributed energy assets, and demonstrate technical innovation and long strategic partners. As a promise, we keep you on, we keep you operational. Thank you very much for your time, and we're looking forward to energy for every future. Thank you.
Thanks very much, Mark. That was great. A lot of innovation there for decarbonisation. Thank you very much. Thank you to all of our presenters for sharing their expertise with us today. Thank you, everyone, and have a great day.